Hey guys, Miss Fearon here. Welcome to Unit 3, Learning Target 4, Dividing Monomials. So our learning target for today is I can divide monomials. In our previous lessons, we've already looked at our product of powers when we've been multiplying. We've also looked at our power to a power situation. And then we've looked at when our exponent has been 0. So we're going to go ahead and we're going to add another rule in here, and we're going to look at our quotient of powers. So basically, when you are dividing bases, you want to make sure that you subtract their exponents. So when we're looking at this example here, I have a to the 6th divided by a squared. I'm going to have a to the 6 minus 2 then, which is going to be a to the 4. So when you divide, you want to subtract their exponents. So let's go ahead and look at example number 1 here. We have 4ab divided by a. So remember, when we divide, we want to go ahead and we want to subtract those exponents. So if they don't have exponents, you have to remember they're imaginary little ones around all these guys. So the only thing that has the same base is the a's. So that 4 and the b are going to stay on top, and we're going to look at those a's. When you have a to the 1 minus 1, those are going to cancel out, and they're going to be gone. So I can go ahead and I can write it as a 1 underneath, or I can just have it as 4b, and that's my answer. So go ahead and look at example number 2 here. Again, these have an imaginary 1s by them. So I already know that my x's are going to end up canceling out. I have 1 on top and 1 on bottom. They're going to disappear. Now that 6 is going to stay there, and I have y to the 3rd divided by y to the 1. So when I divide, I'm subtracting those. So I'm technically doing y to the 3 minus 1, which is going to give me y squared. And I put that on top because that's where the bigger number of my y's were, so that's where they have to end up. So for example number 3, we have multiple pieces to this. So I'm going to go ahead and I'm going to deal with the coefficients first. So I'm going to look at a 5 and a 10. I can't do 5 divided by 10. It doesn't come out to be a nice number. It's a decimal. So when it comes out to be a decimal, I want to look at, is there a number that goes into both of those that I can divide out of each of them? So I know that 5 goes into both 5 and 10. So I'm going to divide this by 5, and it's going to become a 1. And divide this by 5, and it's going to become a 2. So now I'm going to look at my x's. I have x squared divided by x to the 1. So when I do 2 minus 1, I get just 1x left. And the bigger number was on top, so it's going to go on top. And then that y is my only y, so that's going to stay on top of the fraction as well. And that is my final answer. I'm done. Number 4, I want you to pause the video, try it on your own, come back and check your work. So for example number 4, I got 2b to the 3rd divided by 7a. So to get the 2 and the 7, I knew that a 2 went into both 4 and 14. So I took that out of each of them. My a's, I had a to the 3rd divided by a to the 4th. So the way that I do that is I do the bigger number minus the smaller number. So 4 minus 3 gives me a to the 1. And the bigger number of a's was on the bottom, so that's where I'm putting the a. I can do the same thing with my b to the 5th divided by b squared. B to the 5 minus 2 gives me b to the 3rd. And the bigger number of b's was on the top, so that's where I put that one. If you get that one wrong, come chat with me. Let's make sure we find our mistakes before we move forward. So these problems can get kind of big, and so when we're trying to figure out when are we done, we want to keep these 3 things in mind, and we're going to add to this as we start moving forward. But the first thing we want to keep in mind is that each base can only appear once. So you can only have one x, one y, one a, one b, whatever the base is, I can only have one of them left in my answer. I can have no power to a power, so basically I don't want any parentheses left. If I have parentheses, that means I'm not done with the problem yet. I have to get rid of those. And then all of our fractions must be reduced to the smallest they can be. I don't want any decimals though, so don't go and give me any decimals in those. So here's a couple more examples. Number 5, we're going to go through these kind of the same way. I always want to look at the coefficients first. I want to look at the 5 divided by 15. That's not a nice number for me, but I know that a 5 goes into both of those. So I'm going to divide 5 out of both of these. which is going to leave me with a 1 on top, and a 15 divided by 5 gives me a 3 on the bottom. Now, I'm going to go ahead and I'm going to do the x's, my x base. I have x to the third divided by x squared, which means I'm doing a 3 minus 2, which gives me x to the 1. Now, I want to look, where is that going to go? Well, the bigger number of x's are on the top, so that's going to go up on the top of my fraction. So we're going to do the same kind of thing with my y's. I have a y to the fourth divided by a y to the 1, so I have to subtract 4 minus 1, which gives me a y to the third, and the bigger number of y's are on the top, so again, that's going to go on the top. My fraction is reduced. I only have one of each base, and I have no parentheses, so this is my final answer. Number 6, we're going to go into the same kind of way. So I want to look at my coefficients first, and I know that a 27 goes into both of these, so my top number is going to become a 1, and my bottom number is going to become a 2, because 54 divided by 27 gives me 2. Now, I can do x squared divided by x squared gives me x to the 2 minus 2, which basically means x to the 0. And remember, x to the 0 would equal us a 1, so I don't really have to put that anywhere. Then 1/2 would be my final answer. Number 7, I want to go ahead and I want to simplify the top of this fraction before I go and try to divide them. So I want to try to multiply first. So remember, when you are multiplying, we are adding the powers. So I have x to the 1 plus x to the 1 plus 3 divided by x to the 4th. So I end up with an x to the 4th divided by x to the 4th. When you're thinking of this, they're both going to cancel each other out, right? X to the 4 minus 4. When you divide, you subtract. So I end up getting x to the 0, which is then going to, remember, going to equal a 1. Number 8, we want to look inside the parentheses first, and we want to see, is there anything I can do inside the parentheses before I move to that power on the outside? So I can't divide 2 and 3. There's no number that goes into both of them. I only have the one piece, so therefore I'm going to go ahead and I'm going to start with the power to a power now. This power must go to everything inside the parentheses. So when you have a power to a power, you are multiplying. I'm going to end up with 2 to the 4th, and then p to the 2 times 4, which is going to give me 8, divided by 3 to the 1 times 4. So I'm going to get 3 to the 4th. Now, before I go ahead and call it quits, I need to look at this problem. I need to simplify 2 to the 4th and 3 to the 4th. So I know that 2 to the 4th is 16. I still have my p to the 8. And then I'm going to divide by 3 to the 4th, which is going to give me 81. So the last thing I want to look at for our example number 8 is I want to see, can I simplify 16 and 81? Is there any number that goes into both 16 and 81 that I can take out of there? There is not. So I know that this is my final answer. It's in its simplest form. So number 9 and 10 look pretty big and like there's a lot going on, but we're going to take it step by step, and you're going to see it's not too bad. So for number 9, I want to simplify what's in the parentheses first. So I have a 5 and a 6 for the coefficients. They cannot divide each other, and I cannot take anything out of both of those. So I'm going to go ahead and I'm going to leave it as a 5 and a 6. So now I have x to the 5th divided by x. Remember, when we divide, we subtract. So I have 5 minus 1, which is going to give me x to the 4th. The bigger number of x's started on the top, so it's going to stay on the top. And then I still have that y. That y isn't going to go anywhere. Now, since I've simplified the inside, I can go ahead and I can get rid of this power to a power situation. So these all have imaginary ones. So this power has to be multiplied to everything inside the parentheses. So I'm going to get a 5 to the 1 times 2, which is 2. X to the 4 times 2, 8. And then y to the 1 times 2, 2. Divided by 6 to the 1 times 2, which is going to give me 2. So now I can go ahead and I have to simplify these numbers. So 5 squared gives me 25. X to the 8th, y squared, divided by 36. There is no number that I can divide out of 25 and 36, so that is going to be my simplest form, and I'm going to be complete. I know 10 looks pretty big. I want you to go ahead and try it on your own, just like we did number 9. So start with what's inside the parentheses and see if you can simplify that first, and then go ahead and deal with that power to a power situation. Pause the video, try it, come back, and check your work. So for my final answer, I got a to the 12th, b to the 15th, divided by 8. If you got anything different, go ahead and check my work, see what I did, and then check yours, see where you went wrong. If you still can't find it, come chat with me before moving on to the practice for today.